We're going to continue with this idea of how we measure data. Once we have data collected, what do we do with it? And what things are useful for us as we look at this data. So we're going to be measuring the center of the data. And we already talked about the median, it just being the middle term. The mean is the one that is used most often. Whether they use it appropriately or not, it remains to be seen, but the mean just means the average. And so we do use that term a lot. We also use mode, which we're going to talk about in just a little bit. So when you are calculating the mean weight, that just means the average weight. 50 people, you add the weights together and you divide by 50, right? And then you can order the data and find the number that splits the two into equal parts to find the median. Again, this ordering of data is important when we are actually finding the center. So median, it is important. When we're finding the mean, it doesn't matter what order we add those numbers, because the addition property is commutative and it doesn't matter which order we add numbers in, we're going to get that same sum. But when we find the median, we need to start from lowest to highest to find that middle value, remembering that the middle value does not have to be one of the data points. So when we find that middle, it might be between two data points, in which case we would add those, find the average of that, of those points. But again, the mean is the most commonly used one. And there's some examples in your book about mean versus median, which one is most appropriate and what relationship they have to each other. Sometimes they're exactly the same, sometimes one is a lot higher than the other, and that also tells us something. It paints a picture of what our data is like. Another measurement that I mentioned earlier is the mode. This is just the most frequent value. So when I'm looking at a table of data and I have it, let's say, from lowest to highest so that I can calculate the median, I'm just going to look how many times each data point came up. If I'm doing something simple like, how many meals did you eat today, asking a class of 20 students, perhaps there will be 3 people that say 1 meal, and we'll have 4 people that say 2 meals. That is what we're talking about. The mode is the most. So if I had 5 people that ate all 3 meals that day, and that was the highest number in that of all of the categories that I asked about, my mode would then be that 3 meals a day because it had 5 hits, let's say. So that is the way the mode is, and it can be calculated for qualitative as well as quantitative data, which is different than a lot of the data that we have been working with. So we can have any kind of data set and find out that mode. It's the one that is the most often. So when we want to calculate the mean of grouped frequency, we are going to talk about this new notation, maybe new to some of you. It looks like a backward Z perhaps. It means is the summation. It is a giant sigma, capital sigma from the Greek alphabet, and it means summation, meaning I'm going to add up. So looking at what these definitions are, F is the frequency of the interval, and M is the midpoint of the interval. And I'm going to be adding up. Let's just look at the denominator here. I'm adding up the frequency here. On top, I'm adding up my frequency times the midpoint of the interval. Adding all those up, and then I would do that division. My fraction bar means division. So that's how I would calculate the mean of grouped frequency tables. That means, well, I think there's an example on the next slide. Let's find out. I have to stop the pencil first. Okay. Here we have between 4 and 5, right? That's not a very good example. I'm going to go back to this. So this is going to be used when I have those tables that we talked about, like a histogram, where I start from 0 and go to 5, and the next category would start at that 5 and go up to 10. So I'm going to be looking for the midpoint there. Because I can't tell precisely where that data lies, I'm going to say that all of those, however high it is, let's say it goes up to 5, all of those data points in there are at that midpoint. So I would say that there are 5 in that category, and I'm saying that midpoint is 2.5. This formula tells me that I will multiply those together for the top, and then I would divide by just the sum of the frequencies. So that is how I use that. This is the frequency times the midpoint, and down here is just the sum of the frequencies. And that is how we calculate it for grouped data. The skewness of the mean, median, and mode. If the world is perfect, it can be a completely symmetrical distribution of data, right? Where in the middle I have the most, and I have it going down perfectly on both sides. This is absolutely symmetrical. In a perfect symmetrical distribution, the mean and the median are the same. They're going to be right down that middle. The world is usually not perfect, and so here we have a skewed distribution. In this distribution, we have that the mean, I'm going to underline this part right here, the mean right here. Notice that the mean is less than the median when I do the calculations on these numbers. So my mean is less than the median, and they are both less than the mode. That gives me more data on this side, do you see that, than on this side. This is called being skewed to the left. More data on the left side. So it's being pulled kind of out to the left. And that happens when the mean and the median are both less than the mode. So that's something we'll talk about, skewness, in this chapter. So that's one way to define it. Here we have it skewed the other direction, right? If I kind of draw from the midpoint there out, I got a lot more data going on the right than I do on the left. And this means, that the mean is the largest and the mode is the smallest of those three statistics. So here's a nice summary. If the distribution is skewed to the left, that's what this is. There's more data on the left. I'm sorry, this one is skewed to the right. The previous slide was skewed to the left. The mean is less than the median. If the distribution is skewed to the right, the mode is often less than the median, which is less than the mean. So something to refer back to so that you can kind of catch an idea of how this is going and which way we are skewed. Sometimes there will be simple questions to be answered of which way is this data skewed, and you can answer it by referring back to this diagram. We're almost through this week's work.